Hello, this is Beltran, I guess. Anyways, right now I'm going to talk to you about the derivative of the unit circle and activity, and how they doing this triangle thing. It will help us understand more the unit circles and the concept that we're going to go through right here. Okay, so first of all, we're going to start out with a 30 degrees angle. As we can see, I put the triangle in the first quadrant because that's how it is, and let's assume this is 30 degrees. I know it's not perfect and all this stuff. Okay, so first of all, we find the rules for the special right triangles, which we just Google simply, and we found that this side equals 2, this side equals 1, and then this side equals radical 3. As we know, the circle, or the unit circle, the radius equals 1, and if we imagine a circle right here, this will be our radius. So this must equal 1, so we just divide everything by 1, and then this will be 1, this will be 1/2, and then this will be radical 3/2. Okay, so what do we do from here? We know that the length from here to here is radical 3/2. So right here, and this point exactly is going to our point is going to be radical 3/2, 0, because it's right here. Yeah. In here, we keep the same x value, but we increase by 1/2. So we go radical 3/2, 1/2. Yeah, and right here, of course, this is our origin. This is 0, 0. Okay, so now we're gonna try to find the values for each of our thingies right here. So our radius is going to equals 1, obviously. Our x, as we saw over here, it's radical 3/2. And our y value is 1/2. Simple, just like this. Okay, now for our x 45 degrees angle. Okay. Let's pretend that's straight. Anyway, so right here, this is our 45 degrees. Our rate, the special rules will be for this time radical 2, and then this will be 1 and 1. Say Juan. Okay, anyways, so our radius has to be 1, so we divide everything by radical 2. However, if we remember from algebra or geometry or something, radical 2 cannot, there cannot be a radical on the denominator. So what we must do, we must convert this by multiplying both sides by radical 2, which in turn will give us radical 2/2. So this side, what would be actually radical 2/2, radical 2/2, 1. And I'm sorry for that, that was my phone. Okay, anyways, so our origin will be 0, 0, as always. Our point right here is going to be radical 2/2, 0, since there's no change in y value. And right here, we're going to be radical 2/2, radical 2/2. Simple as that. As before, we're going to try to find the radius, x value, and y value. Radius, as we said, this is a unit circle, so it's going to be 1. X value is going to be radical 2/2, because since we changed from 1 over radical 2. Our y value is pretty much the same thing. Okay, now for our last angle, it's going to be the 60 degrees. Oh, okay, never mind, let's do another one. Okay, so right here, and this is our 60 degrees, and this is 30 degrees. So if we remember from the our other triangle, this is the same thing basically. This is gonna be 2. It's gonna be radical 3 and 1/2. No, it's not exactly the same thing. It's kind of inverted or flipped or whatever you want to call it. And so that's how I remember, at least. which is pretty much a 30 triangle flipped. We divide everything by 2 because our radius we want it to by 2, so it's going to be 1 radical 3 over 2, and sorry, this was 1 and now it's 1/2. Okay, so our origin is going to be 0, 0. This point right here is going to be 1/2, 0, and over here is going to be 1/2, radical 3 over 2. Now, if you notice, this point right here, it's the opposite of this point. It's just like you just flip them. That's all. That's all you gotta remember. Just memorize one and you memorize the whole thing. Okay, so R, X, and Y. R is 1. Our X is going to be radical through. Damn, I can't pronounce right. Radical 2 over 2 and radical 3 over 2. Wait a second. Yep, I messed up. It's 1/2. Yep, sorry about that. And that's it. That's ours. This is the triangle, and then under this video I'm going to write or explain to you mostly how this triangle is going to help us in the unit, understand the unit circle and the whole concept. Thank you.